Thank you very much, and I appreciate being here. Very exciting place and lots of very exciting discussions here. I'm going to actually start from a completely different perspective. Instead of investment, I'm going to talk about liability. And the whole purpose, I'm the chief data scientist at AIG, and we are actually trying to transform the whole insurance industry. So if I were to go forward here, if you really want to think about quickly about insurance industry, we really do lots of work in terms of insuring risks of various types, which generates premiums, and which certainly it goes into our investments of various types. At the same time, as soon as we insure a risk, then there is a liability already in terms of future, in terms of claims of various types. And liabilities could be 70, 80 years long. If you think about life insurance, for somebody who's just born now, it may be even 100 years from now. So we would have to think about providing for all the liabilities which would come out. And that also we'll have to then think about in terms of matching it so that there is enough liquidity for paying for those liabilities. So that's the whole purpose in this part. And I'm going to really talk about the liability side of the house itself. If we were to really think about it, the key part in all of this liability is how to get ahead of high severity, a long-tail event of various types, as you can see in this picture. And that's always an important part for all of us. And what are the critical elements? Obviously, data of all types and scenarios, probabilities, behaviors, outcomes, insurance, and so on. And data science plays clearly an important role in all of this. If you want to think about the first thing, most important thing is the data itself. How correct is this data? How clean is this data? And those are very, very critical, important thing, which is firsthand I experienced in my own research career when I was involved with Challenger disaster, when because of the faulty data, there was a faulty analysis, and ultimately Challenger was launched. And in fact, I was involved with National Academy of Sciences to look at it and come up with a probabilistic risk analysis framework for this, which is now being taught in many, many textbooks across the world. So I want to tell you first, whatever we talk about, data correctness and data cleaning is an important part of all of this. The second one, which is very critical, is in terms of at least the current movement in terms of data science has all to do with substantial amount of unconventional data, whether it's language, natural language, whether it's video. And if you think about it, just last year, there are 50 million terabytes of data related to video, which went on internet itself. And if you want to think about otherwise sensors, and they're expected to be around 1 trillion sensors in the world by 2024. And the amount of data it can generate and what it can do is going to be very, very critical. As a part of sort of motivating what we can do within this space, I'm just taking an example which started around 6-7 years back when, as a CTO at Rand Corporation, I helped start a new company which is doing quite well. And I'm going to talk a little bit about thinking about long-tail event and what does it mean and what can we do within that space. So if you want to think about from insurance industry perspective, one of the biggest catastrophe from liability side has been asbestos. So asbestos costed more than almost $80 billion around the world, and tens of thousands of lives were lost. So and many insurance companies went bankrupt, and many companies went bankrupt. So you can imagine that if we could ever figure out what could be the next asbestos, it could change the whole landscape in terms of safety of the world as well as financial part of the world itself. So one of the important things which we started was related to, is there any way we can think about chemicals which are entering stream of commerce, and can we identify what could be the way to think about it in some fashion? We can wait for FDA, we can wait for NIOSH, we can wait for everyone else, and they take many, many years, and we won't even know the answer necessarily. Some of the investigations are 15 and 20 years long. An example is like bisphenol A, which I'm sure all of you are aware of it. Now we all have soft bottle to drink for water. It used to be hard bottle. That was all bisphenol A or BPA, and which is now supposed to produce reproductive cancer. In many places it's banned. And same thing has happened to MTBE, which is an additive in the gasoline. And it causes, instead of, it reduces air pollution, increases water pollution. So there are all kinds of such kind of examples. So one of the key hypotheses when we weren't talking about big data was to thinking about, can we think about somehow the other proxy in terms of what could be risky. And one of the key insights which came in was the whole idea that if you think about medical science, constantly researchers are writing their papers and writing about chemicals and potentially relationship with other chemicals and what could be effect and so on. Can we not somehow capture that as a part of it and start the whole process? And can we build some machine learning and other kind of technologies on top of it? Of course, the task was very, very daunting, and we actually mined around 20 million articles which were appearing on PubMed itself. And it was just amazing, and actually number of papers have been written, patents have been granted, and so on. So I won't go into the detail, except I want to just show you just quickly that as a result of all these algorithms which we developed and so on, you could see sort of create a heat map of nothing but variety of chemical agents against the harms of various types, and there were taxonomies had to be created and other kind of things. And you could see potentially that bisphenol A and reproductive cancer is nothing but highlighted pretty well. And actually, there are other examples of that type which would come out in terms of other kind of chemicals, which we could show, which were really important from perspective of potentially becoming for future, was N-propyl bromide is the additive which is used in terms of dry cleaning chemicals. And it's supposed to create some sort of some sort of neural damages. And TC is being used for cleaning supplies, and that's causing some sort of kidney failures. And the interesting part is diacetyl. Many of us walk around the corridors and we smell this beautiful smell coming out of popcorn, and you smell the butter and your mouth starts watering, and it turns out that that's nothing but a chemical and not a real butter, and that's causing some lung issues. So I just want to tell you that these are the kind of things which can become important. And in fact, we were able to find before even some of the regulatory actions were taken place, like in BPA, regulatory action took place in terms of only just recently in US, and Europe was earlier than that. And you could actually see from this kind of mining that what can happen in terms of this part of it. And this whole approach has now become generalized, and lots of things have been done. But I just want to show you the whole thing from perspective of liability. And if you really look at insurance books, then all of this has got huge liability already. But if it was people were to follow this kind of advice in some meaningful manner, it can change complete paradigm and could reduce the risk of various types in terms of billions of dollars. So that was one example of it. I want to move on to another example, which is related to probably closer to all of you in terms of variable annuity, all this guaranteed insurance contracts of various types. Guaranteed insurance contracts typically have some sort of surrender value, and then they have some sort of guarantee. And typically, if surrender value is higher than the minimal guarantee, then perhaps some people will actually surrender it. And there's a whole issue of surrendering. Once you surrender, then we have to pay the liability related to that. We have to cash out our investment. And then the whole issue comes out to be what is the gap and how many people would be doing it. Traditional approach has been more like a balance sheet level, that we'll just take a look at how many people did last quarter get off and the year before, and then we do all sort of actuarial things like data triangles. You might have heard about data triangle kind of technologies. And that's one way to do it. But and if interest rates go up, then what would happen to surrender value? There are all kinds of those kind of calculations. And they're at extremely highly aggregated levels. And it sort of generates all kinds of unhedgeable liabilities. So the question is that what can we do, and how can we predict this liability? Is this the best way to do it? This would work under normal circumstances, but if there are contagion behavior of various types, it doesn't work well. So the question is, can we not go at, instead of aggregated macro level, can we go at a micro level? So there are all kinds of challenges. How do we go at micro level? How do we aggregate at macro level? And how do we think about it? And here are a number of potential things which can happen, which is that if you were to think about this from behavioral side of it, then you might want to think about that actually insured are all heterogeneous, and there is heterogeneity. Consequently, when you look at a chart, people surrendering before surrender value is actually lower than the guaranteed insurance contract, then in that case, still they're surrendering it, which doesn't make sense from a variety of perspectives. But if you go at a micro level, You can see people's behavior based on the income and based on the other part of it. That would be something very, very worthwhile. And one can actually create the whole utility maximization kind of ideas within this context. And one can actually use some sort of discrete choice models and add them up and so on. So I just want to sort of point out to you some of the challenges, and maybe those are the challenges where all of you can help in terms of how do we think about this part. And then the last one I want to just show you is this new data. And this is the last chart, which is that here is Hurricane Sandy. And here is a picture taken by actually helicopters we flew there. And we wanted to see what could be the damage, and can we detect damage, and can we differentiate the damage itself. So there is a lot of work going on in terms of computer vision and sensors, and how do we differentiate between them are the kind of things which we look at it and try to estimate a damage, estimate a variety of properties, and so on. So I just wanted to give you how machine learning is transforming the insurance industry. And with that, I'm going to stop and going to let...
Stay there.
Okay, I'll stay there.
You're
Sure.
still on the spot for another 5 minutes.
Sure, perfect.
So you talked about predicting liabilities from what we would call in our field a meta-analysis of the literature.
That was one example of it.
Right. And
Not all the examples.
not all of them. And I've seen a lot of these meta-analyses, and they always report on their successes. How many things did you identify as risks that turned out not to be risks?
So actually, it's a very interesting question, actually. There are a whole issue of false positives and false negatives, as you are correctly pointing out. And not only that, if you really want to think about it, here we had 80,000 chemicals, and we had more than 100 harms. So if you want to think about statistically, it's a large number, it's a multiple hypothesis problem. Absolutely. So you're going to have lots of false positives in some fashion, but then there are ways of correcting it. And there has been huge amount of literature which has gone in terms of false discovery rate and other kind of things. To a great extent, and then what happens is on top of this thing, analysis which comes out, we have a special method of expert elicitation. Given all of that, to a great extent, I can't tell you exact number because I don't remember, sorry, I apologize, because I'm not associated. This is a company I helped started, but I'm not anymore part of it. I used to be on their board also. But it has been quite successful, and insurance industry has actually accepted this is one of the important standards.
Okay. So I will ask the audience for questions. Well, if not, I'll ask you another one, but
Sure.
I'll give the audience a chance. So for many years, AIG was an enormously successful insurance company because it sold insurance. And then it got involved in a lot of very complex financial products because it had the technology to do so. Is it inevitable that large financial institutions will be involved in products that no human being can understand because the technology has generated them?
Well, obviously, I think what happened during at least 2008 had much more to do with the investment side of the house in terms of financial products. No,
Well,
I just want to
yes,
tell
had
you
that-
that.
they had
I
that-
just meant
you had
I just
that
want
group-
to clarify this. Sorry.
You had
I
that
just
group
wanted
in
to-
Connecticut doing very fancy things.
So this was all run through England, as you may remember, this financial product part of AIG, which was greatly involved in this. And clearly, those derivatives and so on, I think all of you are really taking into account all of those right now. And today there was a lot of meaningful discussion. In terms of liability side of the house, there have been disasters like asbestos, and certainly natural catastrophe. Like if suddenly you had a 7.9 earthquake in California, what would happen is a big issue. But I think this is where really we have learned our lesson over the last 15 years, going back before even 2008, that we're not only managing at the insured level, but we are managing at a portfolio level. So we are always trying to diversify to what extent earthquake in California are potentially related to earthquakes in other places in the world. And we try to manage the portfolio in some fashion, such a way that we do not ever break the bank from perspective of portfolio. And same thing is now happening in terms of environmental risk, in terms of chemical risk, that at no place, as soon as we figure out, at no place our portfolio would exceed certain kind of events which could be disastrous.
Yeah.
But that's the part which we get paid for.
Yeah.
So we have to cover those. But we cover, for example, satellites, we cover aircrafts, we cover almost everything in the world, including cows in India with RFID tags. So we actually also try to reduce the risk by doing risk mitigation strategy using RFIDs and sensors.
Thank you.
Thanks.